Okay, so today's aim is what are the following terms and how do they relate to triangles and line segments. So these are the terms we're going to learn. Number one, an altitude. The second one is a median. Third one is an angle bisector. And the fourth one is a perpendicular bisector. And you're going to be taking notes. So get comfortable with that. Okay, first thing is the altitude of a triangle. What is the altitude of a triangle? So the altitude of a triangle is the perpendicular segment from a vertex of the triangle to the line containing the opposite side. So what I'd like to do is put your player on pause, make sure you have this definition down in the theorems and definitions section of your binder. So the altitude of a triangle is the perpendicular segment from a vertex of the triangle to the line containing the opposite side. An altitude of a triangle can be inside or outside the triangle, or it can be a side of the triangle. First of all, let's make sure everyone remembers what a vertex is. So this is a vertex right here. This is a vertex. So a vertex is the common point of two rays. Here's one ray, here's the other way. So this is a vertex. A vertex is also the common point of two line segments. And very often the line segments we're talking about are the line segments that make up a triangle. So here is a vertex. Here is a vertex. So let's take an example. So it says the altitude of a triangle is the perpendicular line segment from a vertex of the triangle to the line containing the opposite side. So if you take a look at the vertex B, we have a line segment BC, which is the altitude. It is perpendicular, as denoted by this little box over here. This is an acute triangle, and the altitude is inside the triangle. So notice how it says that an altitude of a triangle can be inside, and this is an example where the altitude is inside the triangle. But there are also cases where you have the altitude that is a side of the triangle. So for example, in a right triangle, the altitude is a side. So this is the altitude right over here. BC is the altitude of the triangle. In this case, BD is the altitude of a triangle. Another example is when we have a triangle that is an obtuse triangle. So for example, whoops, let's get rid of that. In an obtuse triangle, what I needed to do to create my altitude, and the altitude in the obtuse triangle is this BD. This is the altitude. What I needed to do, as you can notice, is I had to extend AC. AC is the leg, one leg of the triangle. In order to drop an altitude, because remember an altitude is a perpendicular segment from a vertex. Here's my vertex B. In order for me to draw a line perpendicular to AC, I had to extend AC to point D. One thing to note that's very important is this piece, CD, that is not part of my triangle. That is not part of triangle ABC. That is an extension of line segment AC. Okay, so let's just talk about altitudes for a moment. So I have three vertices, right? Every triangle has three vertices because every triangle has three sides, and the vertex is where the two sides meet. So there are three vertices, which means I should be able to draw three altitudes, and that's exactly correct. Let's take three different types of triangles. Actually, it's the same triangle, the triangle ABC. What I'd like to do is I want to use the same triangle ABC to draw three different altitudes, one from each vertex to the opposite side. So the first one I'm going to do is I'm going to take this triangle ABC. I'm going to draw an altitude from A to BC. Now notice how there is a problem because I can't draw a line from A perpendicular to BC inside my triangle. As you can tell, line AC, one of the sides of my triangle, is already not perpendicular to CB. So what I need to do is I actually need to extend the lines. What I'm going to do is I'm going to extend this line, namely BC, and now what I can do is I can drop an altitude. So I'm going to drop an altitude from A perpendicular to that line. So, and I'm going to, whoops, let's undo that. And what we're going to do is I'm going to call this D. So AD is the altitude of triangle ABC. AD is the altitude of triangle ABC. Notice how AD is perpendicular to BC. What I needed to do is extend line segment BC. I needed to extend the leg of the triangle BC. Let's do the same thing here. I'm going to draw an altitude from C to AB. Here I drew an altitude from A to BC, but I had to extend BC in order to drop that altitude. In this case, I don't need to extend anything. What I can do is I can simply drop an altitude, which I'm going to do. Let's get a dashed line. There we go. And I'm going to simply drop an altitude from C, and we're going to call this, let's call this D. Okay, so we're going to call this D. So notice how what I did was I dropped an altitude from vertex C to AB, and I'm going to call that point D. So CD is my altitude. So I drew an altitude from C to AB. Now I'm going to rotate that triangle again. It's the same triangle ABC, but this time I'm going to drop an altitude from B to line segment AC, to the side AC. Now you notice again, I'm going to need to extend my one leg of my triangle. I'm going to need to extend the leg of my triangle, and I'm going to do that just by drawing a dashed line. I'm going to draw that. I'm going to just extend a dashed line, which will be an extension of AC. So let's do that. So I'm going to extend AC, and now what I can do is I can drop the altitude from B perpendicular to AC. It's actually a line that is drawn perpendicular from B to an extension of AC. So there I go, and this is D. So notice how in triangles, for these two triangles, for the triangle on the upper left and the middle, I had to extend one leg of my triangle. But that is this is an altitude, BD is an altitude. AD is an altitude, that is an altitude, and CD is an altitude. Okay. So those are altitudes. So let's review for a moment. How do we use the definitions of altitude, median, and angle bisector of a triangle to solve problems? Well, first, here was the altitude, and an altitude is the height of a triangle drawn from a vertex perpendicular to the opposite side, which is what we saw here. These are all altitudes. What I have in blue here, and let's make this blue also for consistency. Okay, these are all altitudes that I just drew. Now, what about a median? Okay, so a median, let's take this down in our notes. A median is a line segment drawn from a vertex, in this case vertex B, to the midpoint of the opposite side. D is the midpoint of line AC, or of side AC. How do I know that D is the midpoint? Well, these hash marks tell you that D is the midpoint. D basically breaks up AC into two equal pieces, AD and CD. So since D is the midpoint of AC, line BD, line segment BD, is a line that's drawn from a vertex to the midpoint of the opposite side. That is known as a median. So BD is a median, and it creates two congruent segments, AD and CD. So BD is a median. It is a line drawn from a vertex to the midpoint of the opposite side. Therefore, BD is called a median. What was the last thing that we wanted to define? So these belong in your notes, folks. If you don't have them, put your player on pause and make sure they're in your notes. The last thing we needed to define was an angle bisector. So an angle bisector is a line segment that cuts an angle in half. So one thing to notice is that BD bisects angle A. And what that means is as follows. It means that angle CAD, CAD is, let's do this over here. Angle CAD is congruent to angle BAD. And we denote that by using these little arcs. So AD is an angle bisector. Okay, AD is an angle bisector. Why? Because it is a line segment that cuts an angle in half. It creates two congruent angles. Which are those two angles? Angle CAD and angle BAD. These two angles are congruent to each other. Let's make sure we do not make a mistake and make any assumptions. Let's go back to the median. BD is a median. It is a line drawn from a vertex to the midpoint of the opposite side. It does not tell you anything about what BD does to angle B. It does not necessarily bisect angle B. And in this case, you can tell it does not. ABD and CBD are not congruent to each other. These two are not congruent. So a median is not the same thing as an angle bisector. Also, let's take a look at the angle bisector. The angle bisector bisects angle A. In other words, AD cuts angle A into two equal pieces. It does not necessarily bisect line CB. As a matter of fact, you can tell here it does not. CD and BD are not congruent to each other. So that's important. So we have altitude, we have median, we have angle bisector. These belong in your notes. The diagrams belong in your notes as well. If you need to put your player on pause, go right ahead and then hit play to resume. Okay, the last thing we're going to do is define a perpendicular bisector. So a perpendicular bisector is a line drawn perpendicular to a second line that also bisects the second line. To bisect means to do what? To bisect means to cut into two equal parts. And this, of course, is in the definition section of your binder. Perpendicular, we know what that is. And how do we denote that DE is a perpendicular bisector of AC? Very simply. We notice that there are two hash marks between AE and CE. That's telling us that line segment AE is congruent to line segment CE. So DE is bisecting AC. What else do I know? DE is also perpendicular. Whoops, I didn't mean to do that. DE is also, let's do this with a highlighter. DE is also perpendicular. DE is also perpendicular to AC. And you can see that because you can see that DE creates this perpendicular sign with line segment AEC. So DE is perpendicular to AC. DE is also the bisector of AC. So we call that a perpendicular bisector. Okay, so DE is a perpendicular bisector. DE is a perpendicular bisector. Okay, it is perpendicular, denoted by this. It is a bisector, denoted by these right there. Okay, let's see if we can solve some problems. So, identify the medians and altitude. So, for PQ, triangle PQS, is PR a median and altitude or neither? Let's see. PR is this piece right over here. Let's see what that is. So PR is this. So what is PR? Well, it looks like it's drawn from a vertex. It looks like it's perpendicular to QS, or an extension of QS. Well, if a line is drawn from a vertex perpendicular to the opposite side, that would make it an altitude. So PR is an altitude of triangle PQS. Let's take this down in your notes to make sure you have this example in your notes. Let's take another example. For triangle PQS, is QT a median, an altitude, or neither? And explain. Okay, so let's see. QT is which? QT is this side right over here. So QT is this side right over here. Well, let's see. It's drawn from a vertex, okay, but it is drawn to the midpoint of the opposite side. How do I know it's the midpoint? Well, these two hash marks tell us that PT and ST are the same. So if it's drawn from a vertex to the midpoint of the opposite side, that would make QT a median. So QT is the median of triangle PQS. Make sure this is in your notes and look forward to seeing it in your notes tomorrow.